Hi, good people. So, in this video, we are going to talk about ordinary and singular point. So, we're going to find the differences between these two. So, in the last video, we talked about the definitions. There is Y definition, there is Y prime definition, there is Y double prime definition. So, this one is for Y, the function Y. So this is the same as if we extract the terms. We're going to have a sub 0 because if we plug in 0 in this subscript here, we're going to have a sub 0. If we plug in 0 here in this power, we're going to have 0 and anything raised to 0 except 0 itself is 1. Okay, so here we're going to have 1. Okay. Then we say plus a sub 1, then this is your x minus x sub 0, then to the power 1. Okay, then we say plus your a sub 2, then x minus x sub 0, then to the power what? 2, then this continues. These are the triple dots. Okay, this continues to infinity because this is the infinite series. Okay, so I said if x naught is equal to 0, the function y will be n is equal to 0 to infinity a sub n, then this, okay, let me just write it, minus 0 to n. Okay, we're going to have what? N is equal to 0 to infinity a sub n, then this is going to be x to the power n. Okay, so this is the definition of y. So I recommend, if you haven't watched the previous video, please watch it so that you get the understanding. You get the understanding of what are we doing here, what are we dealing with. So we have this special equation. The equation is p of x. It's p of x, then y double prime. We're dealing with second order, so we have double prime, then we say plus y q of x, then y prime plus our r of x, then y is equal to 0. This is the second order differential equation. This ODE is the second order. We have our y double prime. If we had here maybe y, then we have our triple primes there, that would be the third order. So we're in the second order now. So we're dealing with second order. Okay, so we have these functions here. We have this function p of x, we have this function q of x, we have this function r of x. So if p of x naught, okay, bear in mind that is x naught. If p of x naught is not equal to 0, then we say x naught is an ordinary point. Okay, ordinary point. x naught is an ordinary point. So if p of x dot is equal to 0, we say x naught is a singular point. Okay, so you should bear in mind, if you plug in your x naught in this, let me highlight this part, in this function p of x, if you plug in your x naught there and you get 0, you should bear in mind that is the singular point. If you don't get 0, you should bear in mind that is the ordinary point. Okay, let's take an easiest example. Easiest. So we have d squared y. Okay, then this is d of x, dx squared minus 8 dy over dx plus your 15y is equal to 0. Okay, so to check if it's ordinary or singular, you should check this function. If you notice, this function is the coefficient of y double prime. This function is the coefficient of this one. Okay, so you can rearrange, or sorry, not rearrange, you can rewrite this as your y double prime minus 8y prime plus your 15y. Okay, so what is the coefficient there? So our function, our p of x is 1. Okay, it's 1. So is it, this is 1, so is it a singular point or an ordinary? Is it a singular or ordinary? So since p of x is equal to 1, then let's say we are given that x naught is 0. Okay, if you plug in your x naught here, you still get 1. Your x naught is what? Is 0. You're still getting 1. Okay, so this means, so this x naught for this case is equal to 1. This is not equal to what? 0. This means we are in the ordinary point. So these two cases, in these two cases we are going to use an ordinary point. Okay, so for the second example, let's say we have let's say your this is your x squared minus 4. This is y double prime, then minus maybe x squared y prime plus your y is equal to 0. Okay, now you're given that your x is what? Your x naught is 2. Let's say it's 2. So here you are going to check if is it singular or ordinary. So the first thing you should first look at the equation. So your equation, you can just see it that it's a second order differential equation. So this second order we have a coefficient here, which is a function. Oh, sorry. So this is a function. This function is our p of x. Okay, this function is p of x. So p of x y double prime plus your q of x, then y prime plus your r of x, y is equal to 0. Okay, then this p of x, we have p of x here, which is x squared minus 4. Okay, so if you plug in your x naught there, if you plug in your x naught, what is your x naught? This is your x naught. So your x naught is 2. So it's 2 squared minus 4. Then this is 2. Then you're going to get 4 minus 4 is equal to 0. So for the ordinary, what is the case for the ordinary? Your p of x naught mustn't be equal to 0. This is the ordinary case. So for the singular, the p of x naught must be equal to 0. So you should bear in mind those cases are very important. So this means the equation we're having here is a singular point. Is a singular point. Okay. So we have the ordinary point. So for the ordinary point, p of x must not be equal to 0. Okay. If you plug in your x naught here, you shouldn't get 0 for the ordinary point. So for the singular point, p of x naught must be equal to 0. Okay, so these are the cases that we're going to deal with. We're going to solve the second order linear differential equations using these two cases. So for the ordinary point, p of x shouldn't be 0. Then p of x should be 0 for the singular point. Okay. So we have a singular point. We have a singular point. We said p of x naught should be equal to 0, isn't it? So now the most important part is to identify if is it a regular singular point or irregular singular point. Is our x naught a regular singular point or irregular singular point? So you should know how to identify those two uh, terms, not terms, two differences. You should know how to identify those two differences if you are given the singular point. Is it regular or is it irregular? Okay, so this is our equation: p of x y double prime plus your q of x y prime plus your r of x y is equal to 0. Okay, so now you are going to do what you did looked at the equation, you did evaluate the equation, and you have concluded that this is a singular point. So then the step that you are going to do after, you're going to try to identify if it's regular or irregular. So that step, you're going to do what? You're going to divide by that p of x. You see, sorry, this is p of x. So you're going to divide by that p of x throughout. I don't know why I'm writing p of x. Okay, you're going to divide by that p of x throughout. So you're going to be left with y double prime plus your q of x. This is your p of x y prime plus your r of x, then p of x y is equal to 0. 0 divided by p of x is 0. Okay, so you have that piece of equation. So a singular point uh, has two differences, or let me say quantities. So it's a regular point, singular point. Then you have irregular singular point. Okay, you have those two. So for this one, a regular singular point, you are going to take these functions. There is this function here, this one. You're going to take this function and this one and find the limits using these functions. So this, you're going to say the limit of x approaches x naught, then this is your x minus x naught, then your function, which is q of x, then this is your t of x. Okay, then you're going to find the other limit. The other limit will be the limit of x approaches x naught, then this is x minus x naught, the whole squared. This is squared. Then you have your r of x divided by your p of x. Okay, then if you have a finite for both of these limits, okay, these limits, if you have the finite uh, results for both, when you are evaluating these limits, let's say you evaluate this and get the finite result, also you evaluate this and get the finite result, this means it's a regular singular point. When you say a finite, I think I should uh, give clarity. Finite means it's a quantity that has a value. Okay, its value, you can identify its value. If let's say you get the here the limit, uh, this limit, let me just say the limit here is 10. Okay, the limit here is -2. These are finite. Okay, if you get infinite means infinite. Okay, if you get infinite means infinite. I just wanted to give clarity on those things, infinite or finite. So here for a regular, you should get both of these limits a finite result. Okay, this one should be finite, this one should be finite. So now for irregular, this part, the irregular, it's either this. Okay, let me write this part. The limit x approaches x naught, x minus x naught, q this function of p of x. Then the limit, we have the same limits, but the results can differ. Okay? This is squared. Then you have r of x, you have p of x. So if here you get infinite, here you get a finite result. Maybe let's say a is in arbitrary, so you can have any value here. So, or maybe you have here a, you have infinite here, or maybe you have infinite and infinite. This means this point is irregular. Okay, this is the irregular point. You get for the first limit infinite, you get infinite. Then the second one you get a, a finite result. For the second case, you get a finite result. For the second case, sorry, for the first, we are in the second case. This is, let me just say the first. Okay, this is the second, this is the third. Okay, in the first case, maybe the first limit you get the infinite result, the second limit you get a finite result. Then the second case, maybe you get in the first limit the finite result, then the second limit you get the infinite result. Okay, then the third case, maybe both limits you get infinite result. So this means if you get either, this is the irregular. So for regular, you should get finite results uh, for both limits. This limit, also this one. Okay, so this is the singular point. So if you find this recording helpful, please like. Also comment. I would really appreciate your feedback. Thank you.